We are delighted to introduce MadhavVyas, who is the coding curriculum expert at Lead Group. With over 13 years of rich experience spanning both IT and education, Madhav brings a unique blend of industry expertise and academic insight. He began his career at Wipro as an analyst, but his passion for education soon led him to the classroom, where he served as an assistant professor at leading engineering institutes in Mumbai, including D.Y. Patil Institute. Driven by his vision to bridge the gap between theory and practice, he also founded a training organization dedicated to preparing undergraduates with practical job-ready skills. Since 2020, Madhav has been deeply involved in the edtech sector, designing and implementing coding programs in India and the US. At Lead Group, he is at the forefront of shaping 21st century coding curricula that empowers schools to equip students with future-ready skills. Madhav holds a master's in engineering, is an ISTQB certified software tester, and has presented research at international conferences on coding education outcomes. Please join me in welcoming Madhav Vyas, a passionate educator and leader shaping how coding is taught in classrooms today, to the webinar. Thank you, Madhav, for doing this for us. Now over to you. We are excited to learn from you. I also have less knowledge of coding, so I'm really looking forward to this webinar. Thank you. Over to you.
Thank you so much, Karima, for the kind words. Uh, I hope my screen is visible.
Yes.
Okay, all right. So welcome all the audience here to this session on classroom strategies to teach coding. One of the key topics very close to my heart, which actually led me to join the education sector. And I'm very excited to interact with all of you. I know that a lot of people have come from different backgrounds in today's session. Principals, school owners, teachers, academic coordinators. Really excited to walk you through today's agenda. Uh, so we will be first of all understanding the key objective of coding. What is the psychology of introducing coding in schools? Uh, Before we get into strategies on how to teach coding. So that will be the next thing we take up. And at the end, we will have a reflection on whatever we have learned. I would like to know from you some of the key takeaways. How do you wish to incorporate in your school? So without further ado, let me get into our webinar. I would like to start the session with an interesting fact. That I came across a few years ago. While I was researching about coding education in India, the very first trigger was having known that Western countries have been teaching coding in their schools for almost 20 years. This really created a huge curiosity in me as an educator back, because I was teaching for undergrad students at engineering college. That how is coding basically taught to kids? What is the motivation behind it, right? And I was really fascinated about it. Before I reveal, why has it been taught into schools? Here is a poll. We would like you to participate and share your opinion for. What do you think is the core reason why coding is introduced so early in schools? What could have been the thought? Whether in Western countries, if you would like to take a guess, what could have been the motivation? And now that we all know coding is widespread in India too. So here's a poll that you all can see on your screen. I would like your inputs on that. And then on that note, I would also like to tell all of you that we will have a lot of polls coming throughout the session, uh, so that it's interactive. I get to know what do you think, what are your inputs. All right. So some of the reasons listed here are: it makes them job ready in software engineering field, to build logical ability, to build problem solving skills, and it helps with better understanding of maths. Okay. We'll have a few more seconds till you all can respond to it. All right. Any more inputs? Okay, great. Yeah. So this is the response that we have got. A lot of people have said that it's to build logical ability to, build problem solving skills. And a few have also voted for making them job ready, better understanding of maths. Okay. So, let's see what's the core reason. Yeah. So coding today is like, today's literacy, much been like how maths has been for the previous generations. It builds logical ability and problem solving skills. That is the first motivation to introduce coding. Second is it enhances creativity and computational thinking. And lastly, it prepares the students for tech driven world, right? While I say this, let me also make it clear that schools who have been introducing coding very clearly, very strongly, are clear about the fact that coding is not just to make everyone a software engineer, because that is not the goal for everyone. Every child has a unique skill, unique capability. However, the kind of world that we live in today, we all are always motivated to be comfortable with technology. And in this technology era, we would want our kids not just to passively consume or to wait for technology to grow and just keep waiting. And once they reach college or once they start working, only then realize how we have to deal with it. That's not the goal. The goal is to make them ready much ahead of time. And that's why coding is introduced much earlier in schools today. Now, a lot of you may have questions because we also know that we are not just in the era of coding. We are already experiencing AI advancing with such a rapid speed. A lot of you may have heard about it. AI can also code. So why should kids actually learn coding in today's AI era? Right? That may be a question. I knew some of you already may be thinking about it. And here's the key insight for all of you, that to be the creators of technology, we would need our students to understand the fundamentals of it, right? So we would not want our kids to just passively use any AI tool given to them. We would also want them to have an understanding on how it may be working in the background. Now, why do we want that? We want it because we want our students to excel in the AI tools or in the AI world, whichever tools are given to them. They can efficiently use it, and an individual can only efficiently use a tool when they actually understand how it works, what is the background about it, right? And that's why we would want the students to harness AI and not just rely on it. And that is possible when they have a coding fundamental, because it builds that muscle memory on understanding how technology works in the background, right? Now, as they deal with AI in today's time, we also want them to come up with their own innovative solutions. You may have come across a lot of terms, AI agents, which are already taking over a lot of manual tasks, a lot of smart tasks also, by the way. And it doesn't necessarily need everyone to know coding. But for anybody to use that, having a coding background is of immense help. And people from various backgrounds, irrespective of their educational uh, specialization, have already started using AI into their day-to-day work. And having a tech background definitely helps. Trust me on that. I have a lot of friends in IT, and they tell that even if I'm not into coding, but I do come from a technical background, or I had some exposure in my school to coding, and that really makes a lot of difference. So we essentially want our kids to be future ready, right? Irrespective of the field that they take, technology and AI is always going to be there for them. So we want them to be ready for it, right? Now, I was wondering, going back to the first point that I raised, that what actually makes coding education so successful in US? Like, parents and students are crazy for coding education. They host summer camps until internet wasn't widespread. They used to have summer camps, and students really used to be excited, right? And I was wondering that I have not seen that kind of excitement around in India for a subject like coding. People dread and at times, fear that it is going to be too complex, or why should I learn? At the end of the day, I don't want to be a software engineer. But why is it so widespread in US? What makes it so successful? So while I was thinking about it, I first researched on their curriculum. Is it the curriculum depth? Is it the simplicity because of which everyone is enjoying? And to my surprise, I realized that there is something more. Curriculum, of course, is one of the key pillars, but I soon realized that is not the only thing. And before I reveal you the exact reason, what actually is the reason why coding became so popular and successful in US, let me take you to 2015 and share a small story. This is a real life experience. I was teaching at an engineering institute back then, and Python programming was introduced for the very first time in engineering institute. And I was very excited because I just started researching about it, and I was very excited that we are going to have Python in our curriculum. But there came a challenge for all the teachers that the curriculum demanded uh, multiple lab activities, right? The way it was designed, we could sense that this can be best driven only if we conduct the sessions in lab. However, there were some drawbacks. Ultimately, at the end of the curriculum, there was no mention of any practical exams to be conducted, just some oral exams and theory exams to be conducted thereafter to test students' understanding. And we were a little puzzled, and I could already sense that when I announced this to our students that we are going to learn Python, a lot of them are going to be excited because students today are already well versed. They are much ahead of time. So like since they were all excited, we are going to learn Python. But we soon realized that the due to limited lab availability, uh, because multiple departments were running in the same institute, we had some challenges into conducting multiple practical sessions. We were only getting one practical session a week, and me and my colleague we discussed what is the way out to it. So we came up with a proposal that let's allow students to use mobile phones because it was an engineering institute, so they already had mobile. We thought let's make our theory classrooms itself a practical session. So we created a WhatsApp group of our class. We used to be prepared with some of the problem statements and programs that we are going to give them in the classroom. So we used to explain our fundamental concepts, and we used to ask them to do very small coding pieces that can easily be done on a mobile application. So we asked them to install some of the Python interpreters, tools which support Python programming on mobile. A very basic level programming, but easily you can do it. So we asked them to do it. And we soon realized, students were really enjoying it because soon after a 5 minutes of concept explanation, we used to ask them to open their mobile phones and try out the code that we used to share them, on the WhatsApp. Soon this picked up pace and we started, seeing suddenly students' interest uh, rose to a next level and they were always eager on when can we have the next Python session. They would in fact at times ask for more Python session beyond the timetable also. But as the complexity grew, we understood that this may not be the best efficient way as the code length was increasing. So what we decided, we will be ready in the classroom with the pre-coded template, and we will just focus on the key concept of the class and ask them to fill only that space. The concept that we are going to teach it in the classroom, we will ask them to fill the code snippet of only that part. All right. And we soon realized that this was turning out to be an even more efficient way as students were immediately able to apply what they were learning. And with all of these experiences, students' interest into coding and all other technical subjects grew so much that they started demanding practical implementation for each of the subjects. And that year, I remember very fondly the kind of projects we saw in our annual project exhibition were supreme, were very different, and we never expected students could achieve something like that, right? But why did I share this Python story with you? First of all, the reason was I basically wanted to tell you that that experience showed me that coding education best works only in a practical environment. Even if the curriculum or the syllabus that is given to you doesn't pushes you to do every session in a lab, still as a teacher, it's our responsibility to ensure give them as much practical exposure as possible, right? And that led me to have three big takeaways for my life as a teacher. That the goal of coding education is ultimately to check whether students are able to build the projects or not. Secondly, I understood that whatever may be the curriculum, how rich it may be in terms of concepts, unless we don't have a practical execution of it, we are not setting the stage for learning. So we really need that practical curriculum. And lastly, we have to tie all of these experiences to a project so that students are always excited to build something. So, like I said, in the Python classes that we used to have for the college, we always used to define a problem statement, a key goal that they are supposed to accomplish with the code that they build. And that really builds the excitement, that I've been able to do it and I've achieved the objective compared to any random coding activity. So that project is a very strong hook for any student to learn coding, right? And hence, the core message of this session is that don't teach coding in a classroom. So the most effective classroom strategy to teach coding is that you don't teach coding in a classroom. Instead, you enable students to build projects, right? And on that note, here is a poll time for all of you. I would like to know from you how often do your students visit a computer lab and what exactly do they do during those labs? Okay, all right. So we can see a lot of them mentioning once in a week. Great. And a few schools have also voted that their students visit more than once a week. That's great. And a few entries on once a month, once in 2, 3 weeks, and no set pattern depends on lab availability. Okay. All right. Let's have another poll now. Garima, can you initiate that?
Yes.
So, would like to know from you what do the students do during those lab sessions? You will soon see a poll on your screen. I would like to have some inputs from you.
I am not able to share the poll, Madhav. Just give me 10 more seconds, please.
Yeah, sure. In case there is a challenge, we can take the inputs on
Yeah, I
chat.
think we should take this one for chat. Yeah.
All right. Okay. So teachers would like to read in the chat that what do they do during the lab sessions? Teachers, principals, owners of the school. You can share your experiences on whatever you're aware of. We already have some input. Uh, okay. They build some projects. Some say they practice the programs they studied in classroom. Small Python code is made. Okay. Activities from book are given. All right. Okay, that's great to know. I'll give clarity on why did I ask these questions as we get to the next section of our today's session. So let's understand the strategies to teach coding. We have understood the importance of coding. I've walked you through it, and what is a key message on how coding is, to be taught. Now let's understand some top strategies on how do you make coding education successful. So we are going to see a practical learning framework. We're going to see the importance of real life connection. how scaffolded learning works, how do you bring in project-based learning debugging, and lastly, project evaluation and showcase. Um, First of all, it's important that whenever we are keen on giving any skill-based education to our kids, it's really important that we always allow them to begin by exploring. Traditionally, we have always, in our school days, learned computer science or any other subject for that matter through a very different approach. We used to have a lot of, learning at first, maybe in, maybe at least 4 or 5 concepts get covered over a month, and then we are given an opportunity to do some practical activity. By the time we used to reach to lab, we used to forget all the things that we were taught. We used to hardly remember anything. And we realized soon here, while working with kids, that that's now how kids are going to be excited about learning. Neither are they going to be able to retain it. So we need to give them an opportunity to begin by exploring first. Then we need to give them an opportunity to reflect on what they've just explored, and then teach them formally. And then lastly, build them, an exciting opportunity to build something and master the field. So let's take a quick example on how do we do these things at Lead. Teachers are already a part of Lead group would be able to relate to it already. That we first of all allow students to explore any tool that we are going to introduce or any concept through a video or an activity. So we ask them to watch a video or do an activity which sets the context. So they are basically asked to observe that thing very closely. Next thing we ask them to do is we ask them to basically reflect on the observations. So they have just seen a video and or done an activity. Soon after that, we ask them some questions which makes them think, oh, why did that character move when I clicked, a certain key? Or how was the character able to interact or was able to, move an object? When we make them think after an observation, it automatically, increases the curiosity for the learning that they're supposed to get for the day. And then when you formally introduce a concept, it makes much more sense for them because they're already excited. They already have some hint on, the topic that they're going to cover. And lastly, we give them an opportunity to apply their learning to build projects. So that's how the journey of learning begins from exploration through thinking, and lastly, allowing them, giving them an opportunity to build the project. So that they have learned something, they have reflected upon it, and immediately they build that project. All right. Now, here's an opportunity for you to share your experiences on what all could be the benefits to begin learning by exploring. Does it build interest in learning? Does it provide context before formal learning? Or is it a fun way of learning according to you? All right. So I think uh, a lot of you say that it builds interest in learning, while a few of you also say that it helps in providing context before formal learning, and it's a fun way of learning. So here's the answer. Actually, all of you are right. So it definitely builds great interest in learning because before we ask them to, learn a concept, when we actually show them a video on why that is to be learned or, what are they going to build in the session, they are already excited. And it sets the right context before actually teaching them any concept formally. And when we do all of this, the learning becomes fun. So all of you are right. Thanks for your response there. So that brings me to the next part of it. That is a real life connection. So, starting a class by saying something like, students, today we are going to learn about variables, events, and functions is not really going to spark the excitement in kids. And believe me, as a teacher, I've seen this firsthand. If I say things like this, it's all jargon for them, right? And nobody is excited to learn jargons. Everybody wants to do the cool stuff, something which is fun. And how do we build that fun element? By bringing in a real life connection. And to bring the real life connection, we need to have a story that really excites the kid. So you should always start your coding sessions or any concept to be introduced through a fun story. That story should also, have a challenge, because what makes a story really fun or exciting is the challenge part of it. If a story doesn't have a challenge, even if a normal story or any book that you pick up, the most important thing that you like anything about the story is a challenge, and how is the hero able to overcome the challenge. So that's really important, right? And while you do all of this, making it relatable is really, really fun. Very, very important. Because if you have a great story, you have a great challenge, but somehow the kids in your classroom are not able to relate to it, it wouldn't really serve the purpose, right? The story should also be relatable. Now, how do we bring this into action into classroom? Let's take a quick example. So for here, I have a story in front of you where Raj and Coco are best friends. Every evening they play together, but today Raj has received a lot of homework. So he says he cannot play with Coco, who is his friend and also a computer expert. So he has to solve some mathematical sums and calculate the BMI of his family members. So now Raj has completed all his other homework, but he's not sure how to calculate BMI. So his teacher has taught him some basics about it, but he's not really sure how to go about it. So Coco, who is a friend to Raj and also the mascot for our coding program at Lead, decides to help Raj so that he can complete his homework quickly, and then they can go to play together. So this actually is an example of a story-based setting where we are introducing a kid who has some homework to be done that kids will immediately relate to, because the kid wants to go out and play, but he needs some help, and Coco is there to help. Coco says that we will have to learn basics of Python for it, and I'll help you to create a actual BMI calculator. So when we say things which are in line with some story and a problem statement, and which is very close to something that a kid of that age can relate, it sets the ground very strong for them. So now you don't need to push them that we all are going to learn Python, it is very important because of XYZ features. Kids really don't care about it, whatever may be the richness of Python. All they care about it, where can I use it, how can I make it fun. So that's how you have to come up with your relatable character stories and challenge that builds the excitement. And while all of this is there, in case if your curriculum has this, a teacher also has to ensure that they say it with a lot of excitement. Because if it's just read as a statement, it doesn't really have that impact. So how do we make this storytelling successful? You have to set the context, why to learn. You have to share the possibilities with them. What all can they build by learning Python. And lastly, you have to allow them to collaborate. So when you're bringing a real life learning aspect into your classroom, you have to be very clear about it, that how will students start enjoying it. First of all, I have to tell the context. Why are we learning, and what is the way that the students are able to relate to it. I have to create excitement. So for that, I have to share all possibilities. With Python, you can create apps, you can create games, or with Scratch, you can create XYZ applications, games. And at the end, you also have to let them collaborate. So while they learn all of this, ultimately you have to understand that you're not pushing them towards some high level of technicality. You want them to enjoy this entire experience of learning. And computer science or coding is one such subject which can be made really, really fun. And the excitement level can be increased to 10x if you allow them to collaborate. Just see that magic happening in the class, right? And when I say you allow them to collaborate, have fun, have chaos, this is one such ad which I very fondly remember. How many of you remember this ad? Can you let me know in the chat box? You would have seen this ad, right? Surf Excel Dagache. How many of you remember? Right. Okay. And what was the key message of this? What was the key message of this ad? That there is a kid who wants to play, who wants to have full fun, but is scared at times that if my clothes are dirty, my mom or my father will scold me, and but they have Surf Excel, so their parents let them play, have fun. They're not worried about clothes being spoiled, because they want their kids to really enjoy and not be worried about their clothes while they're playing. So similarly in coding, we have to let them discuss, play, experiment, and at the end we want them to fall in love with coding. And for that, even if a little bit of chaos is there, it's fun to have. So teachers shouldn't really be scared or worried that if I ask them to do something in group, either in form of discussion or an activity, it will lead to a lot of chaos. That chaos is actually good. It will build so much love, because it's all about the overall experience. When they're thinking, when they're coding is one such subject where they're not just learning technical skills, they're also learning to collaborate. How do you communicate effectively, call out if the other person is not able to do right, share your ideas. That's how coding really works. And hence, a little bit of chaos is fun to have. So that's how you bring the real life connection, and that brings me to the next pillar of this session, that is scaffolded learning. Before I talk about this, I would like to know from you, what is the best way to ensure knowledge retention? You will soon see a poll popping up on your screen. What is the best way to ensure knowledge retention? Is it by doing practically? Is it by doing small activities in chunks? Or is it by trying out something that you've just learned, like trying it out immediately? Okay, I see a lot of people saying by doing it practically, and a few people also, supporting that learning in smaller chunks is the best way to retain knowledge. And also, some of you have voted that immediately trying out what you've learned helps in knowledge retention. All right. So again, let me tell you that all of you are right. Uh, Scaffolded learning. What is it exactly? We will learn about it. But let me tell you that all of you are right when what you have just voted for knowledge retention. Scaffolded learning basically means that you break down your projects into smaller achievable steps. Okay. While you do that, you have to ensure that students move from smaller milestones to a complete full-fledged project. So you have to design your activities, your class, such that you allow students to grasp the concept, do projects, but smaller pieces of project, because you cannot expect students to build the entire project altogether, because it otherwise it becomes too complex. And the moment something seems complex, especially a subject like coding, because it's very similar to maths, I've seen the tendency that kids will start withdrawing. So you have to ensure that they are not overwhelmed while you teach anything. You have to teach something and let them apply. Teach something, let them practice. Teach something, let them discuss. Right? So hence why scaffolded learning, it ensures that step-by-step learning happen in chunks. When that happens, students don't need to overburden their brain to remember a lot of things. And ultimately, you allow students to have a specific outcome at each stage. For example, you have just taught them a small concept of loops, and then let's say you have a group activity, a group discussion. You've just given an example on what is a loop. Maybe, clock, the dial of a clock going around is an example of loop. And you ask them that why don't you form a group of five each, and tell me what are some more areas in your real life where you see something happening in a similar fashion. And let me see which group comes up with the most number of examples. That would really build a very strong foundation, because you've given them some time, you've explained them something, given an example and asked them to ponder upon it, right? And same happens in projects also. So let's take an example to understand this better. So for example, there is a project where students are expected to build a Google Doodle animation, something like this. Now I cannot say students, let's learn everything about Scratch. This project is, by the way, built on Scratch. Let's learn everything about Scratch and then build it. What we have to do is we basically teach them first of all how to design background, in Scratch. That is their first step. Then we teach them how do you animate something, and then we immediately ask them to apply it on Scratch. Then we teach them how do you add more effects, add letter animations, add more sounds to it, and then we immediately ask them to apply it. So when we teach them something, a very smaller group of concepts, and immediately ask them to apply, it always leads to a very strong foundation. And when they have built a strong foundation, let's say in skill time one, when they come for skill time two, you can just focus on the new concept because the foundation for the skill time one is already very strong, and then they build upon it further. Likewise, okay. So that's how scaffolded learning happens, and that's why it's really important that we always break down learning into smaller groups, smaller chunks, give them chance to discuss, give them chance to build upon smaller things. And that brings me to the next very important thing, which is project building. Now, for project building, to be successful in your curriculum, these are some golden rules that you need to have enough availability of computers, labs. You should always have an exciting problem statement. Otherwise, you can't really motivate kids to coding. You need to have a very clear, strong problem statement. And the tools should be very easy to learn to begin with. I've discussed with this with a lot of school principals, owners in the past, that what is the best way to learn coding. We want Python education in our school because Python is the most popular language out there. A lot of other schools are teaching. Can we teach them Python? Can we start with Python? So in that discussion, I have to then, based on their previous computer science education, I have to suggest them that what is the best way to learn. And the key summary of all that discussion has always been that make it easy for them to learn. They should have an easy win when they start coding at first, because only then you create that excitement in them, right? So we have to really be careful on the tools that we choose and for which grade are we using that. And we have to allow them to apply all concepts in their project and always ensure that we encourage students creativity when we want to build project. We cannot always have some specific goals that everybody is just rushing around the same goal. We have to allow students to also express their creativity. So in all my recommendation, I've always said that if you want to ensure coding is successful, begin with a block based coding approach, whether it's primary or it's a middle school grade, and then slowly transition to text based coding. And when you transition to text-based coding, always choose Python as your first programming language above any other programming language, because hands down, Python is the most easy to use coding language, the most beginner friendly coding language, right? And when we have the right set of tools, coding really becomes exciting, and hence that's why a lot of our students have been able to build such cool projects. So I'll quickly show you some of the projects that our students have built. Our students have built a snake and ladder game. And by the way, these are the projects of primary grade. And also students have been able to build app on MIT App Inventor. So here is one such app which we cover in our curriculum, where the students build a AI-enabled SOS app using MIT App Inventor. And the intention to show you these projects were that when you show these projects to students at the beginning of your class, uh, half of your work is done because they're already hooked. Now they're just excited to build that. And then the right approach to be followed is what we just discussed on building upon smaller chunks, seeing one skill at a time, right? And that brings me to the last aspect of this key strategy on how do you ensure that a student who has learned everything, you've established the real life connection, you've ensured that scaffolded learning has happened, you've taught them how to build project. Ultimate goal of coding education is to build projects, right? And how do you assess then a subject like coding, right? That is what we are going to see next. I would like to know from you, how do you assess coding skills today in your school? So here's a poll coming for you, and you have to be honest about it. How do you currently assess your students? Okay. Is it through oral exam, through MCQs test? Is it through a detailed written test? Is it through projects? All right. I see mixed responses here. A lot of you say through projects, written tests, MCQs, and a few also say through oral exams. Okay. All right. So the reason to ask you this was essentially to know what is the current thought process, and honestly, I have seen this during a lot of my interactions with schools that students really enjoy to code, students really enjoy building projects. Uh, Teachers are taking the efforts to teach them coding, but at the end, the evaluation is not happening right? And the key reasons why many schools that I've seen miss to evaluate coding through project-based assessment is one is that they think that oral exam is sufficient because if a student is able to recall what is a loop, what is an event, they are good enough to go. And one of the most famous reason is that this time we had no time, but next time when we get time, we will ensure that we evaluate practical skills on time, right? And this is a never-ending loop because it appears as an extra effort to conduct practical exams for coding, especially for primary kids. For middle school, it may lead to a lot of chaos. But remember that mantra: a little chaos is okay to have, and that's why we need a practical evaluation to happen, of course, for coding skills. But that is through a right structured mechanism. And to begin with, I would say that first of all, you need to have a quality assess framework, a very quality assessment framework to evaluate learning at all levels. Because at first, you want to see that fundamentally have they understood the things. So before you take them, for any practical exam, it's also important that are they able to articulate their learning and convey it in the right way. So of course you need uh, assessments written, either in the form of MCQs, that you need some quality assessment which tests their understanding, but the questions should be thoughtfully designed. We do not just want them to be able to recall the definition. We want them to master, coding skills at all levels of Bloom's taxonomy. So we want them to be able to remember, understand, basically be able to apply, evaluate, and to be able to create something out of it. So you want to give them multiple scenarios. So your assessments should be a combination of questions which makes them remember, think, also makes them apply their learning, give them debugging questions, give them questions where they find out the errors in the code and suggest what piece of code or concept is missing, so that they are able to basically communicate their thinking. Next, of course, you need project based assessment because ultimately you want to see whether they're able to build projects or not. You've seen that, okay, they understand, they remember, and they're able to communicate. Now you want to see whether they're able to translate that into a project or not. And hence it's really important that you have project based assessment. Okay, while you have project based assessment, that's a great way to test their understanding, but ultimately you also want to encourage the culture of project building creativity. You remember I said a few golden rules on making project learning successful. Last one was allowing students to express their creativity, and that can only happen when you have project exhibitions in your school. So make it a practice that either twice a year or at least once a year, you allow students to showcase their projects, not just to you, not just to the parents, but also to the students, other students in other grades. And when they see some of the exciting stuff that their peers or students in higher grades are building, that will build a culture for them to always keep experimenting. And then curriculum will never be a bar in your school. You will always see students coming, going out of the box, out of their way to show their creativity, to research beyond things which are there in curriculum. And you will see soon establish your school, as a leading tech school with such initiatives. So project exhibition is a key. Any school, which is teaching coding right now, right? And to make all of this work, teachers need to step into student shoes really, right? And when I say that, what do I mean? Teachers need to upskill and they need to keep upskilling. They will never have to stop upskilling. That is one mantra that they need to have in their life because IT as a field, coding, computer science as a field, and that too being a teacher, you will always have to ensure that you keep upskilling yourselves because there is a very beautiful quote that I read somewhere: when teachers keep learning, classrooms keep evolving. So teachers, you have to always keep upskilling yourselves to build that right culture. Because when you have, project exhibitions in your schools, students will come to you with a lot of queries, or you may want to mentor them to go, beyond the curriculum also at times and come up with great, creativity. And how can that happen? How do you ensure, that uh, teacher superpower is unleashed? Um, you can go through YouTube tutorials. There are plenty of tutorials on a lot of these technologies on coding education. How do you make cool projects? There are various platforms, online platforms, web-based platforms, mobile-based platforms, micro learning platforms, which makes it very easy for you to upskill whenever you're traveling to work or whenever you have free time, even if you don't have all the resources available to you. And lastly, of course, we have our own Lead Group Academy. So participants who are associated with Lead would already be knowing. And we've been taking a lot of live sessions on tools, project building, how do you build projects with MIT, Python, Scratch. And we also have a lot of self-paced courses, which allows teachers to build their skill from scratch to advanced level and then certify themselves through quiz and a genuine project submission, which is validated by our experts. So this platform ensures that teachers not just learn, but they showcase their learning, their skills through a combination of quiz and project. Because project building is not just for kids, it's more important for teachers at first. Because only when you build projects, you get yourself certified. You validate your learning and you gain that confidence that I can go in the classroom. I can not just teach this project building, but I can also handle a lot of queries. It is because when you as a teacher are able to build a project, you come across a lot of scenarios which may be a question to a student, and you become confident through this overall exercise. Okay. And we've reached the end of the session with this. Last few points before we conclude the session. A bonus for all the teachers, if you want to increase the coding awareness in your school or excel, you need to have AI ability, because it will not just help you to upskill, it can act as a mentor when you know how to use AI rightly. It can boost your productivity and handle a lot of other operational tasks easily for you. It can create customized content for you wherever you need some additional support, and that will ultimately allow you to have more time in making the learning happen, right? Because we see, and I too have experience as a teacher, a lot of our time also goes into a lot of background work, operational work, file work. And when we know how to leverage AI not just for teaching but also for operational work, it will allow us to have some self time, explore, upskill, get ourselves certified, do projects, and then make our classes also fun. Okay. On that note, I would like to quickly show you, just walk you through a few cool tools which are available and which you should definitely try out. One is ChatGPT, of course, very popular. Teachers can use it for everything, right? From uh, brainstorming for ideas on project, if you want to have a project exhibition, to coming up, to making ChatGPT as your mentor to teach you something. Then there's Gemini, which again you can use similar to ChatGPT, but has advanced capability on image generation and no, cap on the number of images that you generate. So can help you with a lot of other things where IT teachers are expected to be, tech support or also help with schools flyer creation. Diffit is one such tool which I would definitely like you all to try, and which will allow you to create questions, customize content. I would like you to try it out, right? I can definitely share the link, but since it's beyond the scope of today's session, hence I'm just skimming through it for now. And Emily AI is one such extension, uh, which can be a Brahmastra for a lot of you. It's a Chrome extension. You can install it in your browser, connect it with your browser basically, and whichever web page or video tutorial you open, you can ask it to summarize for you. You can also chat with it to get more insights. So it will save a lot of time for you. The reason I showed you all of these tools basically is so that after this session, you go ahead, explore these tools, and then come back. So instead of me teaching you everything in this session, I would like you to explore this and make your life easier and give more time to your classes. Okay. Uh, on that note, I would like to, end this session uh, with a small story, a real life experience that I had some time back. Uh, I visited a Bata store after almost, I think, 7 or 8 years. And in this Bata store, I was looking to buy some, comfortable footwear for my father. And I saw a salesman there whom I'd seen 7, 8 years back at the same place, and he was explaining the make of some shoe to a lady with great detail and with great excitement. So while he was explaining, another salesman approached me, but I did not, interact with him. I said I want to talk to the other person since I know him well. So it was a little surprise here. Salesman में क्या preference होता है मतलब he the customer is always in a hurry, but why is he ready to wait? So I waited for the other salesperson to get free. I told him ki, what exactly do I need? What is my father's age and what is the discomfort? And he got me some products. He explained me the benefit of one over the other very deeply. And I was very happy. I quickly bought that. And just when I was about to leave, I thought I should ask him that what exactly is his education background? What is his expertise? Because of the way he was explaining, I felt he comes from an engineering background who knows everything, but is into a sales profession. So I asked him out of curiosity, sir, I would like to know, like, what is your specialization? You explain things with great detail and don't just tell me what is the MRP, right? And don't just ask me for a number. So he said he was a college dropout. He couldn't complete his graduation due to financial constraints. But then I asked him immediately, so then how do you have so much of knowledge? And I'm sure he had more knowledge than the store manager. To which he promptly said, sir, as soon as I took my first job, I got some of the great seniors and mentors around me who created the right environment for me, who taught me that it's not just about selling numbers. It's very important to understand what you're selling. And that has always, that has sown the seed of that curiosity in my mind. So any new product comes, I want to know everything in and out detail. So he said to me that if there is one key message that I always remember to my heart every day that I come to work is always be in the right environment, especially when you're learning, especially when we want to grow. So always have that right environment. And if you are the senior, create that right environment for others to grow. So on that note, I would like to say that create the right environment for kids to learn coding, to build that project building ability into the kids, to give them the right environment. So in future, they thank you for giving them the right environment when they really excel into their individual fields, right? And with that, I hope that we all take this as a key lesson for us. And I would like, there are a couple of things before we end the session. I would like all of you to share your key takeaways of today's session in the chat window. And then there is a surprise for all of you. So, yeah, let's hold on to that surprise. I would like all of you to let me know your thoughts. What are some of your key takeaways for today's session? Uh, you can mention that in the chat for all of us. And then there is a surprise for all of you.
After this, can we take up a few questions that are there in the Q&A window, Madhav?
Yeah, absolutely.
Yeah.
So, meanwhile, I'm just reading the questions. I would like to congratulate you all that you all are set to implement coding education effectively now. And this is just the first step. I look forward to more. And here is a poll for all of you, which was a surprise part of the session. Um, how many of you would be interested to know how to use AI for schools? What is a practical way to boost teaching and learning? How many of you would like to have a webinar on this topic? And if it's something that excites you, and if we see a good number of people interested into AI, how can they add it for their schools as an administrator, as a principal, as a teacher? I would like to know if they would like to have a webinar and we will soon let you know when we can have this. So meanwhile, some of you respond to that. I'll quickly go through the chat and see. All right. So I see a lot of you mentioning that you would be interested into this AI webinar. Okay, thanks for your response. And I'm also seeing the chat responses here. Uh, what are some of the takeaways for you? Making some, I'll just read out a few comments here. So yeah, thanks for all right. First of all, thanks everyone for being active and participative throughout. I'm just reading a few comments. So you would like to make your session more interesting. You would like to make set the context for them. Uh, you would like to emphasize on collaboration, on project building. Great. All right. This seems great. Okay. So now I'm opening the session for any Q&As that you may have. Any questions if you may have, I'll be happy to answer that.
Okay, so we have one question from Bhanupriya. They're asking, can you suggest any Python interface that can be used by students at home for practicing, mostly on phones?
Mhm. So there are a lot of interpreters available on for mobile phones with Python. If they go to Play Store, they will figure out a lot of them. I remember one such very famous and easy to use is Solo Learn is one such app that they can try. I used to use it a few years back. They will have to check. Solo Learn is one such app that they can see. They can definitely use. They will essentially have to search for the keyword Python interpreter. Then there are a few more. I can just quickly check them for you. I recall the name, just trying to initial word for it. Okay. Yeah. Then there is Pydroid, Pydroid, Pydroid 3, which supports the latest Python version. That is again very easy to use. You can see that.
Oh, okay. Thank you for answering that, Madhav. One more question we have is from Tracy. They're asking, it's very difficult to find coding teachers, and we shifted to computer application this year. What course would a prospective coding teacher need to complete for this?
Okay. All right. Uh, so Python for beginner is one such course that you should ask all your teachers to go through. Uh, if they are teaching coding for the first time, but if they happen to come with some computer science background, you will find a number of tutorials on YouTube which teaches on how Python for beginners. I would suggest also an application, Solo Learn, like for which there is also an app, uh, which makes learning very easy. So this basically is a uh, micro learning course, by the way, on Python. They have plenty other courses also, wherein they will teach one concept in 2 or 3 lines, and then they will ask you a question, either a coding question or a conceptual question to test your understanding. So these kind of micro learning apps are also very very helpful for anyone who is new to coding or any such technology. Because first of all, you don't need any tools separately; it's in your mobile, and the way the learning is structured in those micro learning apps is such that one concept is taught in 30-40 seconds, and then you're asked to, given a question to think and then respond to it. So you're connected throughout. You don't have to consume a lot of things, so that makes it very easy. And skill wise, if I have to say, Uh, Scratch is one such application any primary teacher in coding should be aware of. Uh, in text-based coding, Python is one such programming language a teacher should be aware of. If they're not aware, even if you give them a week's time, they at least can reach to a level from where they can start teaching. Python is so easy. And of course, we also at Lead keep having our webinars for our own school. So we keep having live sessions for project building. So a lot of teachers have not taught such subjects in the past also get a good understanding because we enable them to build projects alongside with us. So having said Scratch and Python, web development, HTML, CSS is another basic skills which teachers should definitely have. So there are a lot of YouTube tutorials also available out there. Uh, Code with Harry is one such tutorial. Code Basics is one such platform on YouTube which is available. So these are all free. You can definitely look after them, and then you can also see some courses on Udemy.
Uh, Again, thank you so much, Madhav, for clarifying. We have time for one more question, so we'll take one last question from Bhavya. She's asking, how can we implement AI during coding classes within the given schedules of periods that we have?
Mhm. So first of all, it should be a part of your curriculum. So it becomes easy, obvious to implement it. Uh, Second is, of course, at first you will have to upskill. If you want to go beyond curriculum and try out things, you will have to be that teacher who's excited about technology genuinely. Until you are not excited, you will not be able to create that excitement. So you will of course have to, like I said, you can either use ChatGPT or the tools that I suggested, get a good understanding of them, and then take it to your labs. So whenever you happen to, have your classes, labs, uh, create some space for such AI tool experiments also. In fact, you can extend it to the entire school. You can have sessions for your teachers at first, upskill them once you've taught, because only when you teach to your fellow teachers, you will gain that confidence, and then you can, of course, take it to your classes also. So use such tutorials like the tools that I mentioned. And if you want to have a good understanding on AI, again, Code Basics is one such platform you can learn through. Then there is Krish Nayak's YouTube channel, which is again which goes from basics to advanced of AI. And you will also see, uh, yeah, I think these are enough for now. I think these sources you can definitely start with, and as you get good hang, then you can go to advanced things.
Okay, I think, yeah, we are done with the questions. I would like to take this time to thank you for doing this for us. It was a very insightful session. I think we all learned a lot about coding today. And I would like to request the audience to take the survey. So we have a survey link sent in the chat window. You can tell us how you like the webinar there. You will receive the recording of this webinar and the certificates and the survey link in your emails by the end of the day. Thank you so much, Madhav. Now I will take 2 minutes of your time to introduce Lead Group to the audience.
Yeah.
People who are already associated with Lead, if you want, you can leave. This is for people who want to partner with Lead, who want to know more about Lead. Can you just give me a second? I'll share my screen. Uh, so just 2 more minutes to tell you about Lead, to introduce you to Lead Group. So Lead Group is India's #1 school edtech company. Uh, our motto is to provide excellent education to each and every child of the country. We offer learning systems to schools. What is a learning system? A learning system is a combination of technology, pedagogy, and curriculum. To give you a sense of where we are present and what is our reach, there are some numbers on the screen. We are present in 400 plus cities and towns of the country. We have partnered with more than 8,500 schools successfully. We are engaged with 36 lakh plus students and 60,000 plus teachers as well. So what you get with the learning system, what we offer is world-class books we offer you. Then we also offer you audio-visual learning systems with TVs, and you also get student activity kits. We offer three kinds of products. So you have Lead Learning System, Pinnacle Plus Learning System, and Propel Learning System. These are all customizable solutions according to your school, the type of school you have. These are all customizable. You can reach out to us on the number given on the screen. Please take a screenshot. And you can also mail us at partner@leadschool.in. We would be happy to answer your questions, and it would be helpful to transform your school through Lead. Thank you so much, everyone. Please take the survey in the chat window. Thank you, everyone, for joining. Thank you so much. Thank you, Madhav. Thank you, Shalini.
Thanks, Karima. Thanks everyone for joining.
Thank you.